Good morning. Welcome back. Let us continue from the previous class. So we have stopped at finding the distance between 2 points. So some of you have posted the derivation for it, and here is again a brief outlining of it, how you have to frame it, to derive distance between 2 points in coordinate system. So what we have considered, a x1 comma y1 and b x2 comma y2 are 2 points in the xy plane. The same sentence you have to write here. So whatever you are doing it here, the same should be written. That's all, very simple. Right. Now the next one is draw perpendiculars from A and B onto both axes. You can see that, and BP and AN are the perpendiculars onto x-axis. Right. Now draw AM perpendicular to BP. AM perpendicular to BP. So thus it forms 90 degrees here. Now from figure it is very clear. Already we discussed it in detail and it's only a quick review. So AM is equal to, from figure you can say that this is x2, this is x1, and this part is x2 minus x1, which is of course equal to AM. Similarly, this whole thing is y2, this is y1, and this part is equal to y2 minus y1, which is bm. So am is equal to x2 minus x1, bm is equal to y2 minus y1. Now from Pythagoras theorem, what do you have? ab is equal to square root of am square plus bm square. So square root of x2 minus x1 whole square plus y2 minus y1 whole square. So what is ab? ab, if you want to write it in a formula manner, so it is the distance between 2 points. So just to generalize, I made it as AB is equal to D. That means D is equal to square root of x2 minus x1 plus y2 minus y1 whole square. This is what already we did in the previous class. It's only a quick review of it. Okay. After this class, you can pause the video and you can copy those who wanted to copy it. Okay. Now let us see how to solve the problems using this particular formula. How to solve the problems using this particular formula. As an example, so find distance between P of 5, 4 and Q 6, 7. So what are the 2 points given to us? P and Q. So P, so in place of 5 it is x1. So this is x1. This is y1 because you have considered A to be x1, y1. So here this is x1, this is y1. This is x2 and this is y2. Now substituting in the formula, what is that? Here in this case PQ is equal to, D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Take the value of x2. What is x2? 6. That is the axis of the second ordered pair. 6 minus what is x1? The axis of the first ordered pair. 6 minus 5 whole square plus y2. The ordinate. Ordinate means y coordinate of second ordered pair. That is 7 minus the ordinate of the first point. 4 whole square. So 6 minus 5 is 1 whole square as it is, plus 7 minus 4 is 3 whole square as it is, under root. I repeat here again, you can't split the root because here addition is the operator. Right? So now you have to simplify within the root. 1 square is 1 plus 3 square is 9. So 1 plus 9 is equal to 10 under root. So square root of 10. So D is equal to. Therefore, how do you conclude? Therefore, distance is equal to square root of 10 units. Because this is a quantity where you can have units. We didn't specify here any units. Neither centimeters nor meters. Thus, you have to write just as root 10 units. You have to write it as just units. If it is specified as find the distance and this is at a location of so and so centimeters and all that is given, then you have to write the unit here to be centimeters. Clear? So how to substitute in this? First see, take the numbers or take the points and then compare it with the general points. General points here are x1 comma y1, x2 comma y2. So this is x1 comma y1, this is x2 comma y2. First keep that in mind. Then write down the formula. Then afterwards substitute the respective quantities in this formula and then simplify. Remember, there is a plus symbol here. You can't split the root. So everything should be simplified under the root only. Just leave it like that if you don't have the perfect root here. So square root of 10. Clear? Yeah. Just pause the video for a moment and then copy this one. So done with copying that. So now the next one is, let us see the second example. Distance between, let me name A and B are the points. A 5 comma 2 and minus 6 comma 2. What do you observe here? 2 is same. Simply to the children, those who can do it directly. So here ordinate, that is the y coordinate in both these constants. So 2 minus 2 is going to be 0. So therefore you can just simply say x2 minus x1 under root whole square will be remaining. So x2 minus x1 whole square under root and square will get cancelled. So x2 minus x1 will be the direct answer. If it is asked as a half mark question, there is no need for you to do anything. Just directly by looking at the problem itself you can write the solution. And for the children, those who want some additional explanation, I am giving it here. So first plot the points. Plot the points. So my points vary between 5 and 6. So therefore I need x-axis to be a little bit longer when compared to the y-axis. So let me take, so 1, 2, etc. Let me see. Take it to be 5 and 6. So 1. So here you are directly locating the points. Therefore I am giving it as minus 1. Or you can also say that it is minus x-axis and you can take 1 also. But here, to make it very clear, I am taking minus. Because while finding the distance, you won't say that the distance is of negative value. Distance can't be of negative value. Never mind, nothing to be worried. We can take it as minus 6. Okay, right. So this is half, like depending on my abscissa values, I have distributed my x-axis. You can do it. Right, and then now here it is minus 1, minus 2 and then minus 3 somewhere. Right, I don't need of course negative y-axis. So 1, 2, 3, something like this. Is that clear? So I didn't bother about all these points because I don't need them. I want positive x value to be 5. So I have located this one here and the negative x value to be minus 6. So therefore this one and the positive and in first and the second points you have only the positive y value 2. Thus I did it like this. Now locating the point. Now let us locate A 5 comma 2. So both positive. It will come in first quadrant. Both positive, it will come in first quadrant. 5 comma 2. So 5 comma 2. We'll draw a line parallel to y-axis passing through 5 and draw a line parallel to x-axis passing through 2 as we have defined what are x and y coordinates. So this is A. So A 5 comma 2. Right. Now let us locate B. Where is B? Here you can see that x is negative but y is positive. When x is negative and y is positive, it comes under second quadrant. When x is negative and y is positive, it comes in second quadrant. So now draw a line parallel to y-axis passing through minus 6 on x. So and then draw a line parallel to x-axis passing through y is equal to 2. Here is the point. Here is the point B of minus 6 comma 2. See, directly you can see there is no difference in the y coordinate values. There is no difference in the ordinate values or what we call as y coordinate values. So directly you can just find, that means it is something like that. The line joining A and B, the line joining A and B is parallel to its axis. That means whenever the ordinates are constant, then always the line joining the given points is parallel to x-axis. So we can see that here, right? Clear? Is that clear? So now we wanted to find out this particular distance. We want to find out this distance, the total distance. So clear, 2 minus 2 is anyhow 0. So 5 minus half minus 6. So here itself from the diagram, as we have already dealt, this is of 6 units, this is of 5 units. Total it should be of 11 units, right? Already in the previous class we have studied directly how to measure if it is parallel to x-axis or along the x-axis. So total this distance is 6 units, this distance is of 5 units because axes are 6 and 5. So 11, total is 11. From diagram you can directly say that the distance is going to be 11. This is the second method. First method I said, no need to do anything, directly you can say minus 6 minus 5 because x2 is minus 6 minus x1 is 5. So minus 6 minus 5 is minus 11 whole square under root. So minus 11 whole square will become 11 square because minus square is positive. Under root 11 square, square and 11 will get cancelled. I am sorry, square and square root will get cancelled and you are left with 11. Directly writing just only by looking at this. The second method is locating the points and then determining it from this. The third method, the most general method, like substituting in the formula, AB is equal to D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square, which is equal to x2 minus x1, my x2 is minus 6 minus x1 is 5 whole square plus y2 minus y1, y2 is 2 minus y1 is also 2 whole square under root. So that is minus 6 minus 5 minus 11 whole square plus 0 under root, which is equal to square root of 11 square. The square and square root will get cancelled and you will get finally answer to be 11 units. So what do you conclude? Therefore D is equal to 11 units. I already said that you have to write it as units because it is distance. D is equal to 11 units. Clear? Clear? I have given you 3 methods. One just directly by looking at the ordered pairs, you can directly calculate in your mind and then you can put the answer. Second method is just visualizing it, how to look at this pictorially. So in the diagram also you can do it. And then the most general method, right? Substituting in the formula. Clear? Alright, let us do this one here. Okay, distance between 3, 2 and 3, minus 4. Children who can do by themselves in all these 3 methods, you can just pause the video here itself and then you can just work it out on in your notebook. And those who need my help, please just continue with the video. Right. So the first method here is, see, what is constant here? X coordinate is same in both. Abscissa is same in both. Let me name the points as P and Q. So now 3 minus 3 in either way whole square is 0. So don't think about this now. Now what we are left with is y2 minus y1. y2 is minus 4 minus y1 is 2 minus 4 minus 2 minus 6 whole square under root. Minus 6 whole square gives you 6 square. So 6 square under root and square will get cancelled. So your answer is going to be 6. Direct method. From the diagram, suppose you need to draw the xy coordinate system. Let me see how the values are. So x-axis is varying between 3, means almost 3 units I need, and y-axis 4 units. Right on the negative side it is much longer. So let me take it like this. So 1, 2, 3, 4. 1, 2, 3, 4. Right. 1, 2, 3, 4. 1, 2, 3, 4. I am limiting myself depending on the values given here. Right. So now this is minus 1, minus 2, minus 3, minus 4. And again minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4. 1, 2, 3, 4. Now locating point P. First let us locate point P here. So those who want these details also. Right. P 3 comma 2. So exercise 3. Draw a line parallel to y-axis passing through plus 3, that is on positive axis. 2. Ordinate is 2. Draw a line parallel to x-axis passing through 2 on positive y direction. So point of intersection gives you this point, P of 3 comma 2. What is the other one? Q 3 comma minus 4. So 3 on positive side, already you have the line here, right? And minus 4, minus 4. That means ordinate being minus 4. That means negative y-axis, minus 4. So draw a line parallel to x-axis passing through minus 4. This is the point Q. So what is Q? Q is 3 comma minus 4. You can see that just these two are equal. That means a line parallel to y-axis. So what do we conclude from here? Whenever the points are given in such a manner that the axis of each point is the same, then all the points lie on a line parallel to y-axis. If the axes are same in all the given points, then all those points lie on which line? On the line parallel to y-axis. So therefore these 2 points are lying on a line parallel to y-axis. So here 3 minus 3 is 0, nothing to be worried. And now here directly from this is of 2 units, this is of 4 units. 2 units above the x-axis, 4 units below the x-axis, total together 6. So the answer is 6 units. Answer is 6 units directly from the diagram. Second method. Now the third method, the most general method, that is right. So what is that? PQ, which is equal to distance, is equal to, write down the formula first. Always remember to write the formula first. In which formula you are substituting, that should be known, right, or that should be shown rather. Right. So therefore x2 minus x1. x2 is 3, x1 is also 3. So 3 minus 3 whole square plus y2 minus y1. y2 is minus 4. y1 is plus 2. So minus 4 minus 2 whole square under root. 3 minus 3 is 0. Now don't think about this one. And minus 4 minus 2 is minus 6. Minus 6 whole square under root. This is minus whole square is plus. So therefore 6 square under root, which is here, root and square will get cancelled and you are left with 6 units. How do you conclude? Therefore D is equal to, I am giving the conclusion here because I don't have place here. D is equal to 6 units. D is equal to 6 units. So from these examples, what we are able to learn here, that whenever the ordinates are constant or same in the given set of points. What are ordinates? Y coordinates. When y coordinates are same, then all the points lie on a line parallel to x-axis at a fixed distance. Right? And suppose if abscissa are same, then all the points will lie on a line parallel to y-axis at a fixed distance. Clear? So, in any of the form you can answer this. Suppose if it is asked as a 2-mark question, you need to do the general method. If it is asked as half-mark question, no need to put anything, directly you can write the answer. Sometimes problem will be given like this. That means he will give the picture without giving the problem in words, and he will ask you to find out the distance between these two. So directly you can do from the diagram, because now we are very clear how to find out the distance. Clear? Pause the video for a moment and please copy it down. Yes, done? Okay. We shall go with the next part, that is to prove that given points are collinear. What do you mean by collinear? All the points lie on the same straight line. All the given points lie on the same straight line. Here the case is A 1, 3, B 2, 2, C 3, 1. First let us understand how to draw the diagram here, and from the diagram itself it will be clear for us that they are collinear or not. Then afterwards you can prove using the standard formula. Okay. So let me divide this as 1. So depending on what values I have, so 1, 2, 3, 1. So there is a problem here. One, two, three, 1, 2, 3. I am not bothered now here to take the negative x and y axis. Why? Because there are no negative coordinate points. Right. So 1, 2, 3, 1, 2, 3. Let us locate A. So parallel to y axis, parallel to x axis. Here is A 1, 3. Now B 2, 2. Parallel to y axis and parallel to x axis. So this is B 2, 2. Now the third one is 3, 1. So parallel to y axis and parallel to x axis. This is C 3, 1. Now can you see that all the three lie on the same line? All the three lie on the same line. Clear? They lie on the same line. So from the diagram it is very clear that all the 3 points are collinear. They lie on the same line. But how to prove? How to prove? Now see, try to understand it here. Now from the diagram it is very clear. AC is equal to, that means distance between A and C is equal to AB plus BC. Right? I'll draw it here. This is how your line is. A, C, and here is B. So very clear. This AC is equal to AB plus BC, isn't it? So by using distance formula, what we are supposed to prove? First find out AC, right? So using distance formula, AC is equal to, I will take it as D1, okay, is equal to root of x2 minus x1 whole square plus y2 minus 1, or else let me write it as x1 y1 x2 y2 x3 y3. So I am going to find distance from 1, 1 ordinates to 3, 3. So 1, 3. I will write it as 1, 3. D1, 3. D1, 3 is x3 minus x1, y3 minus y1 whole square. Or general formula you can write it as like, because I am taking it here like this. Don't get confused again. It is x2 minus x1 only. That is the second and the first. But here just to make it very clear, I am writing it like this. So what is my x3 value? 3 minus what is x1 value? 1 whole square plus what is y3? 1, and then y1 is whole square under root 3 minus 1 2 square as it is plus as it is 1 minus 3 is minus 2 whole square, And you know pretty well minus 2 whole square will become 2 square. 2 square is 4 plus this is also 2 square, which is 4 under root. So therefore this is equal to 4 plus 4 is 8, or I can take root 8. So I will write it as 2 into 4. Now here it is multiplication, you can split the root. So therefore root 2 remains the same. Square root of 4 is 2. So 2 root 2. 2 root 2 is 6. So similarly, let this be equation 1. Now between this and this, AB. So I will write it as D12, which is equal to AB. So that is, take from here, I don't have enough place, therefore I am just directly substituting it. So 2 minus 1 whole square plus y2 is 2, 2 minus 3 whole square under root. So this is 1 whole square. 2 minus 3 is minus 1 whole square. So that is square root of 2. Second equation. And now third one. Between what and what? B and C. So D do 2, 3. That is equal to BC. Which is equal to, let me substitute directly between these 2 points. X2, 3 minus 2. 3 minus 2 whole square plus 1 minus 2 whole square. 3 minus 2 is 1 whole square plus 1 minus 2 is again minus 1 whole square. So 1 plus 1 under root is root 2. Third equation. Very clear. Root 2 plus root 2 is 2 root 2. 2 root 2. That is AC is equal to AB plus BC. So how to write the conclusion here? Therefore, from 1, 2 and 3 equations, you can say that AC is equal to AB plus BC. That is equal to root 2 plus root 2, which is equal to 2 root 2. Hence proved. Hence proved that the 3 points are collinear. The 3 points are collinear. Suppose for the given points, if this condition is not satisfied, what should be the conclusion? AC is not equal to AB plus BC. Therefore, they are not collinear. AC is not equal to AB plus BC. Therefore, they are not collinear. So, what is there in proving this? You are using only the distance formula, distance between 2 points. You are first finding the distance between these 2 points, extreme points, and then distance between these 2 points, and then distance between these 2 points. And from diagram, it is very clear AC is equal to AB plus BC. I took this like this in order to compare with this. It is not necessary that you have to draw it like this. You can also just like that you can represent. Okay. So pause the video and please copy it down. And so what have we learnt today? That we have just revised the derivation for distance between 2 points, and then we saw how to apply that formula, and then which points lie parallel to the x-axis and which points lie parallel to y-axis, and then also we have seen how to prove that the 3 given points are either collinear or not. Right? So these are all the things that we have discussed. And then in your school group, I am going to post the exercise so that you can solve and then post it back to me. And to the other viewers, we are from Modern Vision High School, Boinpalli. We also give coaching to IIT Foundation. And for any admission inquiries, you can call on 9951343026. Thank you. See you again.